Welcome back to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be talking about properties of organic molecules, an important topic that comes up in paper 2 in your GCSE Chemistry paper. So let's first remind ourselves what an organic molecule is. An organic molecule refers to carbon chemistry. So these are molecules that contain or are made up primarily of carbons. The term hydrocarbon we need to be familiar with as well. A hydrocarbon is a substance that contains hydrogen and carbon. One of the easiest and smallest hydrocarbons, of course, is methane. Meth or meth meaning one carbon, ane because it's part of the alkane family. Now, of course, hydrocarbons, can have much longer chains than methane. For example, we see ethane, which has 2 carbons. So ethane has 2 carbons. We call that eth because it has 2 carbons. But you could also have decane as well. Decane has 10 carbons. So 10 carbons, and we can use the 2n plus 2 rule. So that's 2 times 10 plus 2 is 22. So we'd have 22 hydrogens attached around it. Now, this is a longer chain hydrocarbon, but carbon chains can be way longer than that, very long, much longer than that, up to 100 carbons even, okay? So they can be very, very long. And this length of carbon chain will affect its properties, which is what we're going to talk about now. Now, there are 3 properties that you need to be aware of for GCSE. One is its volatility, and this relates to its boiling point, really. So that's the first one we need to talk about. We're also going to talk about its viscosity. And viscosity relates to the thickness, whether it flows or not. So for example, something like honey or molasses is very viscous, whereas something like water is not very viscous. It flows quite easily. And the final one we're going to talk about is its flammability. And this is also referred to in regards to flash point. Okay, meaning at what temperature will a substance ignite? So volatility, viscosity, and flammability. Now, it's the length of the chain that affects all of these. So the longer the chain of the carbon, the longer the chain, the less volatile. And that means that it will evaporate easily. Sorry, it will not evaporate. Okay, so the longer the chain, the less volatile, meaning evaporation is much more difficult. And this is to do with, as carbons have longer chains, there are more intermolecular forces. We're just going to use the term IMF, forces. And that makes the chains basically stick together, and they're harder to overcome these forces. So the longer the chain hydrocarbon, the less volatile, it evaporates more difficult. Okay, it's more difficult to evaporate. It's less volatile. Why? Because there are more IMF forces the longer the chain, which are harder to overcome. So you're going to need a much higher temperature in order for them to evaporate. Well, let's look at viscosity. Viscosity is similar. The longer the chain of the hydrocarbon, the more viscous. The more viscous, meaning the thicker it is. Okay. And again, this relates to There's more IMF, more intermolecular forces, and that means that they're harder to overcome. So in order to actually cause the hydrocarbons that are longer, very long chains to flow, they actually had to be heated up. And you'll see that used, for example, in fractional distillation, as you want the crude oil to move along into the fractional distillation column, they have to be heated up in order for it to get moving. And power plants use this as well when they need to move heavy fuel oil along a pipeline. It has to be heated up to allow it to move. Now, flammability is the opposite. The shorter the chain, the more flammable it will be. More flammable, and the lower the flash point. And this means this is because there are less bonds that need to be broken. So the very short chain hydrocarbons, like methane, for example, are extremely flammable. Whereas the longer chain hydrocarbons, like heavy fuel oil, in order for it to actually light on fire, you have to apply a lot of energy, and it actually doesn't burn very cleanly. So this is going to be very important, these properties, because these properties determine the uses of the different hydrocarbons. So the properties of these organic molecules in terms of their volatility, their viscosity, and their flammability help to determine what they're going to be used for. So as we said, if we look at a short chain hydrocarbon like methane or even ethane, which has 2 carbons and is saturated with hydrogens around it like that, or even, let's label that, ethane, or even ethanol. This is one of the alcohol groups, so it has an OH functional group on the side. We call that ethanol. These are all short chain, so they're very volatile. They evaporate very easily. Methane is a gas already. They're very flammable because they have short chains. And if they were in a liquid form, they're not very viscous. Not very viscous, I should write. Let's rewrite that. So they're very flammable because of the short chains. And they're not very viscous. Longer chain hydrocarbons, for example, heavy fuel oil, and even things like diesel fuel, they actually are different. They are not very volatile, they are not very flammable, and they are very viscous. And the reason why we have to remember, and I'll write it in red, the longer the chain hydrocarbon, the more intermolecular forces, which we'll just use the term IMF, which are harder to overcome. That means they require more energy. More energy to overcome those forces. A really important topic. And this relates also to fractional distillation, because it is these properties that actually determine the location of the products from fractional distillation. So you need to remember these topics.